Hey everybody, this is Mr. Mack. We're going to talk about ionic versus molecular substances. Okay, so at this point, we've done our notes on inter versus intramolecular bonds, and we know that these intramolecular bonds, the intermolecular bonds, the bonds that are between the molecules, really let you know about how the substance can act on a big scale. So when we talk about ionic substances, that means a metal bonded to a nonmetal. In terms of the bonding that you're going to see, you might consider it ion-ion bonding. But a lot of times it's referred to just as ionic. So it's a little bit tricky that the intramolecular, the one within, sometimes referred to as the one that is between the molecules. But in our web quest, it was called ion-ion. In terms of the formula, what it's going to show, you're going to see a full positive and full negative charge. So our example was NaCl. So you're going to see a full positive on the metal and a negative on the nonmetal. So that's what you're going to see. Types of elements involved, as it said, it's going to be a metal plus a nonmetal. Okay. Now, the bond between the positive and negative, okay, from one molecule to the other. So if I had this NaCl molecule and another NaCl molecule, the bond that's between these is so strong. So this particular bond, that's kind of existing right here, that bond is so strong that ionic substances are always going to be a solid at room temperature. Okay? So what does that mean? Is that in terms of an aqueous solution, so when it dissolves in water, if you have an ionic substance like this, when it dissolves in water, okay, so I got some water here, that positive is going to separate from the negative, and this now sort of looks like a battery, doesn't it? So this positive-negative difference in charge is going to allow it to be conductive in water. So in terms of electrical conductivity, it will be conductive. Molecular substances, which are two nonmetals bonded, the bonding that you're going to see, it could be equal covalent or it could be unequal covalent. So equal covalent or unequal covalent. So that might mean, so in terms of charge, I didn't spell that right, covalent, okay. So in terms of the charges, if it was equal covalent, then that would be no charges. Okay, no charges present. If it was unequal covalent, you would see partial charges. Okay. All right. So types of elements involved, we said, okay, it's going to be a nonmetal plus a nonmetal. In terms of physical state, so what you have in the physical state between these, some of these bonds that are formed here are very strong, all right, or sort of really strong, and you might have a solid, you might have a liquid, or you might have a gas. So you have between the different types of bonds, equal covalent and unequal covalent, your bond strength can sort of vary, okay? So if I was thinking about like ionic bonds as like a super strong handshake, that sometimes sort of the handshake, the bond that's between these molecules here, sort of firm, but not quite as tight as a solid. And then the gas would be sort of a weak handshake, very little attraction. Okay. In terms of the formation in aqueous solutions, so if you take like sugar, for instance, and you dissolve it in water, so you might have a sugar molecule here, all right, and another sugar molecule kind of floating around in there. But it's different than if you had, for instance, our salt. So salt, you really have these positive charge, negative charge separate. In a sugar molecule, the molecule stays intact, but the molecules separate from each other. So because of that, because of how the molecule stays together, these will not be conductive in water. Okay? So that really objective 11 hopefully should explain also objective 12, explain why at room temperature there are molecular solids in all three states, but our ionic compounds are only in the solid state. It has to do with that strength of the bonds. Okay, ionic bonds are so strong they're always solids. However, molecular ones where you have either partial charges or no charges, they have varying strength. Okay, so hopefully that was helpful and sort of ties in how do the intramolecular bonds, ionic, unequal covalent, and equal covalent bonds lead into these big scale ideas, and the intermolecular bonds, the bonds between molecules. All right. Thanks for watching.